Eli Miller, and I'm going to be talking about Leslie Lamport for my oral compendium. An overview of what I'll be going over is his early life, what he's famous for in the realm of distributed systems, how he kind of moved to industry and some of the development of latex. I'll talk about his idea of programming versus code and some takeaways and big picture ideas. So for Lamport's early life, he was first born February 7th, 1941, into a Jewish family in Brooklyn, New York. He received a bachelor's degree in mathematics from the Massachusetts Institute of Technology and received a master's degree and PhD in mathematics from Brandeis University. He worked 7 years as a computer scientist at Massachusetts Computer Associates, worked 8 years at Stanford Research Institute, worked 15 years at Digital Equipment Corp. In Compaq, and then joined the Microsoft research team in 2001, where he still works today. What Lamport is most famous for is his work in the realm of distributed systems. The difference between distributed systems and non-distributed systems is that non-distributed systems are two computers that essentially share the same memory, with distributed systems being different computers or processes that send messages to each other and have separate copies of memory. Lamport first became interested in this topic when he received a preprint of a paper by Robert Thomas and Paul Johnson entitled "The Maintenance of Duplicate Databases." The concept of duplicate databases outlined an algorithm that allowed for multiple copies of data sitting at different computers. There was a big issue with the idea of distributed systems and duplicate databases, and that was that both systems needed to be synchronized in order to obtain consistent views of the data, because at that time, obtaining different sequential views of copies of memory became an issue. Lamport had studied the concept of special relativity and realized that the issue of two observers was analogous to this issue in the realm of distributed systems and duplicate databases. He used this knowledge of special relativity and studied distributed systems in order to develop state machines, which is essentially an abstract computer that can complete tasks sequentially instead of needing them to be synchronized. After a long period of his life being primarily academic, Lamport began to work in industry in order to implement some of the ideas he had produced. Lamport compared programming academically and programming in industry to a painter being able to see nature. He said that even a great painter indoors can maybe picture 10 or 20 different leaves, but when you go into nature, you can see that there are thousands of different leaves in just one view. This analogy represents the number of issues and problems that needed fixing in industry compared to the number of problems that might have needed solving academically. Lamport is also credited with the development of LaTeX, a program that specializes in document preparation. Out of a personal need to write a book, Leslie began to experiment with Donald Knuth's program TeX. After using the program, he began writing a set of macros, which later also became known as LaTeX. LaTeX was eventually taken back over by the TeX team, and it is what's now used today for document preparation. One of the biggest ideas that Lamport wanted to get across to computer scientists is that coding and programming are not the same. He said that coding is to programming what typing is to writing. What he meant by this is that you need to code to program, but to program you can't just code. Lamport believed in an algorithmic and mathematical way of thinking. He stressed the importance of knowing what a program should do and how it should do it before you started coding. He argued that if you didn't have a clear idea of what a properly functioning program should look like, how would you know if it was working and if the work was even done? In summary, Leslie Lamport provided foundational theories and ideas that became the building blocks for distributed systems and are still used to this day. He is sometimes referred to as the man who brought mathematics into the realm of computer science because of his ideas for thinking more and coding less. He developed the process of LaTeX, which are still used for professional document preparation. He suggests that programmers can get stuck with the idea that they need to code more to solve problems when they really need to think more in order to solve problems. That was my oral compendium on Leslie Lamport. Thank you for watching.